Hi class, it's number 5 in chapter 8, or I'm sorry, chapter 8 practice test. So in a recent poll, 130 people were asked if they like dogs. 21% said they did. Find the margin of error for this poll at the 99% confidence level. So you have to ask yourself, is this a mean problem? Are they asking us to estimate the population mean? Because if this is a mean problem, there's a certain formula calculator test that we do, and there's certain formulas that you use for mean problems. But if this is a proportion problem, then there's certain calculator like instructions, and there's certain formulas that we're going to use for the proportion problems. So that's the first thing you always have to ask with these problems. Is it a mean or is it a proportion problem? So let's read it carefully. In a recent poll, 130 people were asked if they like dogs. 21% they did. That's a proportion. They're telling you the amount of people in the sample that either like something, believe something, vote a certain way. They're giving us a proportion. Find the margin of error of this poll at the 99% confidence level. So because they're giving me a proportion, this is strong evidence that this is a proportion problem. Pretty much if this was a mean problem, they would have had to give me the mean of the sample and the standard deviation of the sample. So there's no way this is a mean problem. Okay, so this is a proportion problem. So in proportion problems, you have to go to stats, you have to go to tests, and then you do one prop for proportion, Z interval. So you press that, and then it tells you what you need to enter here. The X value, that's the number of people who have the characteristic that you like, that your desired characteristic in the sample. And that one we have to do a little bit of work for. The N is the number in your sample, and the C is the confidence level. That's all we have to report for this. So I have to make one addition here. The X value is the number of people who like dogs in the sample. So let's go back to the problem. So notice how it just tells us the proportion, the percentage of people who liked dogs. We need the actual number. So we need to find out what is 21% of 130. Well, an easy way to kind of remember that is you just turn 21% to decimal and then multiply it by the 130. I always remember that because like 21 of, there's an O in the of, so that's a multiplication dot. So 21% of a number is just 21% times that number, but the percent has to be in a decimal format. So we just go to find that out. I just go 21 times 1, or 0.21 times 130. Which is 27.3. Now, be careful here. The actual answer is 27.3, but we need to round this because your X value is the number of people that are in this sample with a certain characteristic. So we can't say, there's 27.3 people who answered saying they like dogs, right? We can't have a third of a person say they like dogs. Yeah, it just doesn't make sense. So in order to get this program to calculate our answer correctly, we have to round this answer either up or down. So since it's 27.3 and below, it's 5 and below, or it's below 5, I'm going to go ahead and I have no choice. I have to round this answer to 27. So 27 is the first answer. Now, I believe with the TI-84 calculator, they have you put in a p hat. See, if they just let us put in, some calculators want your proportion, they would have just asked for the 21%. In this problem, they would have just asked for the 21%. That is the p hat is the sample proportion. They would have asked for that. And this particular calculator is asking for the X. And the problem with that is that we have to round. Unfortunately, that's the only way we can get this calculator to do this calculation for us, because it's not going to accept a decimal answer for us as an X value. Unfortunately, they should really let us do the decimal, because it's going to, it's going to destroy our calculations just a little bit. And if I thought it was going to, we'll see how badly, sometimes it may be not enough to cause us any problems. So we'll see. Okay, but I put the 130 in next for this number in our sample. And then the very last thing we put in is the confidence level, and we always put that in decimal format, so 0.99. Okay, and then we just have the lower, and there's our lower and upper bound, our margin of error, and then like our p hat is, it was supposed to be 21 and it's 20.7, so it's a little bit off. So this probably is very close to the answer. Let's see what our answer is though. Oh, so they want the margin of error. So, and they want it to 3 decimal places. So it's 0.092. 0.092. So let's see if they'll accept that answer. And I think it's close enough for government in this case, which it is. Okay, so we're fine. Like technically, I felt kind of nervous because, like I said, we rounded the X value there, but like it didn't affect it. So, all right. I think that there's a wide enough range of answers here that it won't mess it up. But anyways, all right. If you do this problem and it does mark you wrong, let me know. Just email me and I can, sort it out and figure out what's going on. All right. Yeah, just let me know if you have any more questions. This is great to use Class Calculator because they actually have the margin of error. They actually calculate that along with the confidence interval for you. Now, I will say if you're using the TI-84 calculator, there is a little trick that you can use to get the margin of error, even though they don't provide it usually on the TI-84. And what you can do is understanding understanding how we're getting the confidence interval will help you figure out what the margin of error is without having to really look at deal with the big formula that would give the answer to you. So what you need to understand is when they are calculating a proportion, a confidence interval around a population proportion, they take the sample proportion, the p hat, and they add the margin of error to that. And that's how they get the upper bound. Okay, so they take let's say this is p hat in the middle. They take the margin of error, they add the margin of error, and then they get the upper bound. And the way they get the lower bound is they take the sample proportion, and they subtract that same amount, that margin of error, and that's how they get the lower bound. But the secret and the calculator cheat for if you're using the TI-84 is to recognize that if you look at the distance between the upper bound and the lower bound, like this whole distance, it is exactly 2 margins of error. So if you were not given the margin of error like I was, what you could do is take the upper bound, right? This 0.2993336, subtract the lower bound, and then whatever answer you get, like, gosh, let's see, what would I get? And I'd have to go to, I can't do that. I would do 2, 13. So that would be, 13, 12, 16, So that would be 7, that would be 8, that would be 2, that would be 3, 8, and 1. And then what I would do, so this is the distance, the full distance between the upper bound and lower bound. And I would divide this answer by 2, and you'll find that we're going to get the, you're going to get the 0.09. You're going to calculate, that's how you're going to get this middle number, this margin of error. It's another tricky way to get the margin of error, just in case your calculator does not give it to you. And that if you don't want to use the formula to calculate it by hand, then this is a little trick that you can still use to get the margin of error. Okay? You just take the upper bound, you subtract the lower bound, and you divide that by 2, and that'll give you the margin of error. Okay? All right, I hope you guys found this very valuable, and email me if you have questions. Bye.